Good morning, students. Today, let us see NFA and DFA. I am Dr. A.K. Jaithunbi, Assistant Professor from Department of Computer Science and Engineering, RMDEC. Let us see the hierarchy of language first. So, the interior part, that is the inner subset, is your regular language. Then is your context-free language. Then recursive language, recursively enumerable language, non-recursively enumerable language. Let us see DFA, Deterministic Finite State Automata. So it is having an infinite tape broken into cells, and it is one way read-only tape head, and it is of finite control. Now the formal definition of DFA is it has 5 tuples. The first one is a finite set of state. The second one is a finite input alphabet. The third one is a starting state. Next one is the final accepting state. Then is the transition function, right? Now, next, the other definition related to DFA is the language accepted, right? And the transition, that is delta of Q0 comma W, will give the resultant state, and it should be the final state, right? Let L be the language, then L is a regular language if and only if there exists a DFA M such that L is equal to L of M. If you have two DFA M1 and M2, they are equivalent if language of M1 is equal to language of M2. Next, let us see NFA, non-deterministic finite state automata. An NFA is a 5 tuple. It has same as your DFA. The only thing is, for a given input, the transition from one state to another state is 2 power q. That is 0 or more number of states. Right? Now let us see the transition now. What is delta of q0 comma 1 comma 0 for the given diagram? So for q0 comma 1, it goes to q0. q0 comma 0, it goes to q1, q2, q3. Out of this, q3 is the final state, hence the given string is accepted. Similarly, you can do for q0 comma q1 for 1, q0 comma q2 for 1, 0. If you have more than one state, in that case, you are supposed to do union operation. Right? Now, the definitions for NFA, similar to that of DFA, is the language accepted by M, it is L of M, where W is in sigma star, and delta of Q0 comma W contains at least one final state. Another equivalent definition is L of M, W is in sigma star, and W is accepted by the automata M. Equivalence of DFAs and NFAs. Do DFA and NFA accept the same class of language? Is there a language L that is accepted by a DFA but not by an NFA? Right. So the observation what we have found is every DFA is an NFA. DFA is only restricted NFA. Therefore, if a regular language, then there exists an NFA M such that L is equal to L of M. It follows that NFAs accepts all regular language. Let us see lemma 1. Let M be a deterministic finite automata, then there exists a non-deterministic finite automata M dash such that L of M is equal to L of M dash. Every DFA is an NFA, hence if we let M dash is equal to M, then it follows that L of M dash is equal to L of M. The above is just a formal statement of the observation from the previous slide. Okay, that is about the equivalence of DFAs and NFAs. Right? Now, these are the few examples, right? Next, we can see epsilon NFA. And the very important method in this epsilon NFA is Thompson construction. So, in epsilon NFA, you will be having the input sigma with union of epsilon. And similar to NFA, the resultant state will be 2 per q states. Thank you, students. Let us see the problem in the next session.